Hello, am I audible to you? Anyone? Anirudh Sharma, Arafat.
Yeah, I can hear you.
Okay. Hello,
Yes,
I am Shivam, PhD scholar from Department of Physics. So this is our second interaction session for the course Numerical Methods and Simulation Techniques for Scientists and Engineers. So today we'll start by first summarizing the lectures and then doing some examples. And in the meantime, you can ask doubts and any query you have. And it will be good if you will try those examples like with me. So let's start. So it's an interactive session. It is good if you are interactive and try to talk. It should not be a monologue. Okay. We were discussing about different root finding methods. First one was the bisection method. Can anyone brief me what was the bisection method? Anyone? Anurodh? Rafat? I can see Anoop here. Anyone? Or Satvika? I can see Satvika here. Could anyone brief me what was the bisection method?
so today is my first class.
Okay, and you may have seen the lectures from the instructor. There he has discussed. Okay, we'll try. In the bisection method, in the briefly we were uh, we want to find the solution of a curve uh, we want to find solution of a curve f of x as and whose graphical representation something like this. In this method we initially guess two values a and b such that it will lie between the uh, such that the root will lie between these two. To make sure, we'll start with this condition and do the iterations. And the convergence of this method is linear. Like here, error goes down by the epsilon. Then we were facing there. Then we were talking about the second method, which is the secant method. In this method, what we had done for the similar curve. In the last class, someone was asking about the graphical representation of this, so I think this is a good time to tell you about that. So here we also guess 2 points a and b, and we find a value fa and fb corresponding to those points, and we have the iterations such that the x will say which is okay, like x b times here, if we take b times uh, b minus a fb times fa, and here we have the f of b. Am I correct? Anyone could respond me on this? Okay. So here we are basically doing a kind of interpolation kind of thing. If you can carefully see it, like here we have 2 points a and b, and we have done an linear interpolation, and we find a point x, and using these first 2 points we'll find the solutions and give the iterations. And the third one, from this class onwards, this week onwards, which is the Newton-Raphson method. Here we also like fit the function in a linear form, like we do a linear approximation, and here can anyone tell me what was the iteration formula here? Anyone? I'm waiting for you.
Sir, xn is equal to
Yes,
xn minus 1
xn minus 1.
minus f of xn minus 1 upon f dash of xn minus 1.
Okay, this formula is correct. So this formula come from the we are finding we are taking a tangent here, and here we got some point which is the xn minus 1 xn, and we again do a tangent here and find again the approximate point. So using this method we should solve a question. So here I have a question. So we want to find the root of an equation such that x cube minus x minus 1 is equal to 0 using Newton's method. So here f of x is x cube minus x minus 1. F prime of x is anyone?
3x square minus 1.
3x square minus 1. So what is our iteration formula here now? Is this correct?
Yes, sir.
Let us guess. Let us do a guess. So we need a initial guess, which is x naught. So I am, for the simplifying purposes, I am taking it as 1. Okay. So then what will be the x1? x0 minus x naught cube minus x naught minus 1 over 3x naught square minus 1, which comes out to be 1 minus this one. It's 1.5. Anyone getting the same?
Yes, sir.
Okay. So can you solve for iteration 2, which is x2 1.5 minus 1.5 cube 1.5 minus 1 . So what is the value here? Can anyone solve and tell me the value? So what is the value of this function? Okay, I'm writing it down, 0.875, and this is 5.75. Anyone getting the same value? Any person? Okay, Rafat has get the same value. So can you tell me the final value? One 1.347. Okay. For iteration 3, we are with 1.3478 minus 1.3478 cube minus 1.3478 minus 1. It's 3 times 1.3478 square minus 1. So this is bit time consuming, but we have to do it. So what is the value here? We can solve it. It's 2.4483 minus 1.3478 minus 1. This is are you sure, or if it's 1.3251? I am getting 1.3247. Let's solve it here. Plus 3 minus 1. It's 4.4499. And okay, maybe you made some mistake there. Okay. For the iteration 4, what is the value here? X4 1.3247 minus 1.3247 cube minus 1.3247 minus 1 upon 3 times 1.3247 minus 1. So when you will solve it, you will find the value here is 0.0000 something. So we reach our approximate solution up to 4th decimal, which is 1.3247 within the third iteration. Actually, in the 4th iteration we are repeating the same. Anyone has any doubt regarding this method of the calculations? Anyone? Okay, so since numerical methods are famous for solving non-linear equations, like till now we are solving only the linear equations and we don't have any kind of cosine function or the special functions. We are solving only the polynomial equation. So I have an example for the non-linear equation, which is cos x is equal to 2x. We have to solve it using Newton-Raphson method. Can anyone tell me what should be the iteration formula here? Anyone? It was Anoop. Anoop, you could try. Hello? Am I audible to you now? Okay. Rafat was saying, are you facing some problem in your mic, Rafat? Okay. So he's saying in the checkbox, it's cos x minus cos 2x minus sin x minus 2. Anyone has any doubt regarding this? How we got up to this? So this is our iteration formula here. Anoop Sahar is the hand. So do you have any doubt here?
Yes, sir. So
Uh,
please explain.
okay. So since we want to solve this, you can write it as cos of x minus 2x is equal to 0. So our function is f of x is cos x minus 2x, and f prime of x becomes minus sin x minus 2. And since our iteration formula is x of n plus 1 is equal to x of n minus f of x f prime of x, so we just plug in the values here. I think it's clear now.
Yes, sir.
Okay. So let's make a guess, make a conservative guess around how, like, since cos values goes from 0 to 1, like minus 1 to 1, but we are considering only the post value now, so I am making a guess of 0.5, 0.5. So x of 1 becomes iteration 1, 0.5 plus cos of 0.5 minus minus 2 times 0.5 sine of 0.5 plus 2. So since here one thing one should keep in mind, that these values are in the radians. So cos of 0.5 is 0.877. Let's double check. 58 minus 1 times let's sine of 0.5 is it is 0.47942 something. It should not be right. Okay, yes, it could be. And plus 2. We got a value of 2.24 2.47942 and 0.87758 minus 1, it's minus 0.12242. It comes out to be 0.4506. Anyone getting the same answer, same values?
Yes, sir.
Okay, so we will go to the iteration 2. x2 becomes 0.4506 cos of 0.4506 minus 2 times 0.4506 and it's sine of 0.4506 plus 2. So we are getting, so sine of 0.4506 is 0.4355 plus 2, and while the cos of 0.4506 is 0.9001. And minus 2 times 0.4506, it's 2 times 0.4506, it comes out to be 0.08818 and 2.4355. Times this 0.4566, it comes out to be around 0.4868. Anyone getting this? Anyone else getting the same answer? Yes, Anup Saha.
Yes, sir. I have done.
Okay, you got the same answer. It's 0.4868 now. Now we go to the iteration 3. So it comes out to be,
Sir,
hello,
sir,
yes,
in the last iteration part, why there will be a 2 multiplication of 2 here?
here.
Sir, equals to, no sir, in this page. Yeah, x2 equals to,
One second. X2 is equals to
0.4506 plus cos this minus from where this 2 comes.
okay. So here in the formula we have cos x minus 2x.
Oh yeah, sorry sir,
Okay.
got it.
So in the we will go to the iteration 3, which is x3 0.4868 plus cos of 0.4868 minus 2 times 0.4868 sine of 0.4868 plus 2. So sine of 0.4868 is 0.4678 plus 2, while cos of 0.4868 is 0.8838 minus 2 times 0.4868, it's 0.9736. So it comes out to be 8838 divided by 2.4678. Subtracted from 0.4868, it's 0.4504. Anyone else got the same answer? Okay, let's move forward. Iteration 4.
Yes, sir.
Very nice. So anyone has done the iteration 4? Because there I want to point out something. Okay. The upper part of the system comes out to be 0.0005 and the something in the lower. So sine 0.4504, it's 0.4353 plus 1, and the overall correction becomes 0.0005 2.4353. 0.0002. So you can see here since here the value of the functions reduces almost to the zero, and here the correction terms comes out to be around 0.002. So since when you are reaching near the solution, you will find that the answer you got from your previous one will be near to 0, since our overall motto is to find a solution such that f of x is equal to 0, and here basically we are finding f of x, and it tells us, it also points to you that you are going in the correct direction or not. It's a good check if the values are decreasing from upward to lowerwards as we are increasing the iterations. It's a simple check for your calculations. So anyone got the answer here? Anyone? So can we move forward for the, since now this is the last question for the root finding, now we'll go for the interpolation. So any doubt or anything here? Okay, we'll go for it. So we have learnt about the interpolation and why the interpolations are required. So how many interpolation methods we have learnt in the lecture? Can anyone give me the names of those methods? I could see here the Rafat. Rafat, can you? Or Anoop?
Sir, please repeat what are you asking?
I was asking like in the lecture, instructor has told us about the two methods for the interpolation for interpolating the values. So what are those methods? Can you name? Okay. Rafat has answered.
Neutral boson and second method.
For interpolation, not for the root finding. Okay, maybe this will help. So he has talked about the two. First, he has discussed about why the interpolation schemes are required. Since we want to find out the values at like since we for a measurement or something, we have the values for some points like x naught, x1, x2, x3, and we have some value f naught, f1, f2, f3, and since using those values we want to predict at some x which is in between those these points or somewhere else, uh, what is the value of the what is the most probable value of the function here. So we want to make a kind of a determination from this the data available, so we use the interpolation techniques there. So he has introduced two techniques, which is Lagrange interpolation and the second one is the Newton's interpolation technique, or Newton's divisor or dividend, something like Newton's interpolation technique. So first we will discuss about what is the Lagrange interpolation technique. Can anyone brief me out what is the Lagrange interpolation technique? Any hint, any idea or something? It could be a good revision for you also for solving the assignment or something. Okay. Who else was there? It's Satvika.
Sir, I haven't done seen the classes here.
Okay.
I was weak for the past 1 week.
Okay. So in the Lagrange interpolation technique, since as I talked about, like we have the values at some point of a function, of a particular function. Okay, so what we want to find out, like we want to find out a polynomial function such that we want to fit out these points in a polynomial function maybe these are the points we have: f1, f2, f3, f4, that corresponding to x1, x2, no, x0, x1, oh, x1, x2, x3, x4, sorry. So we want to find a point, fit out a polynomial function such that it will pass through all these points and will get a value there. So in that session, in that thing, we'll design a function p of x such that which should look like this: f node as l0, l1, f1 of x, l2, f2 of x, l3, f3 of x. Since we have only now the 4 points, so we are going up to this, and the condition for this l is such this l should be 0, should be the function of x. Lx should be, l node x should be 0 or li when x
Sir,
is equal
is
to
it similar to Taylor series like?
no, it is not Taylor series. It is kind of where we want to find a function which is passing through all these points. So for those, like if I put p of x node, it should give me a 0. That kind of thing I want to find, or it should give me f node, like we have the value there. Similarly, p of x1, f1, p of x2 should be f2, and p of x3 should be f3. That kind of thing we'll get. So since I can give you here only the formula, or should I drive the formula here?
Derive.
Okay. So since we want to find out, since this we have this polynomial, and we want to find out the polynomial such that it will give the values, these values at different points which we have. So in that case, li at xi should be equal to 1, and li should at xj is equal to 0. It means where I is not equal to j. So in the compact way, I is equal to j and I not equal to j. Is it clear to everyone? Anyone has any doubt regarding this? Because this is the crucial point here. Clear? Okay.
Yes, sir.
Okay. So if I'll find a I'll write a polynomial such that x minus x naught, x minus x1, x minus 4, x2, x minus x3, and this will be 0 every time if I put any value regarding the given value x naught, x1, x2, x3. So if I am finding a value with finding a coefficient at L1, we want it such that it should be 1, not 0 at x is equal to x naught. So we'll remove this and put a constant. We want and it should be such that L1 L0 x naught, for the x L0 it should be equals to 1. So the constant comes out to be 1 by x naught minus x1, x naught minus x2, x naught minus x3. So for L0 x we got x naught minus x1, x naught minus x2, x naught minus x3, and in the above we got x minus x1, x minus x2, x minus x3. Anyone has any doubt? Any doubt regarding this expression? So we can write it down as I is equal to 1 up to 3, and the multiplication goes out to be x minus xi and x naught minus xi. And if I write it more general, in the more general fashion, I naught equals to j so in the compact way we reach out at our formula not equal to x0. Here the j, since we have the formula there, p of x should be L0 x0, L1 f0, L1 f1, L2 f2, L3 f3. So we can write it down as summation of j equals to 0 to 3 Lj fj. And since our Lj, or we can generalize it for the Lj, so it comes out to be j is equal to 0 up till 3, and summation, its multiplication, x minus xi, xj minus xi, and I from 0 to 3, and I naught equals to j. And for nth order polynomial it comes out to be j from 0 to n, I naught equals to j, and I have to add f of j here. Is this clear to everyone? How we got this formula? Anyone has any doubt regarding this? Rafat has some doubt. Oh no. So we can proceed further here. So I think this will be clear when we'll do some example, I think. So let's do an example where we'll use this formula and find out the thing. So let's start with the simple example. We were given value of a function f at 2 points, that is x is equal to 2 and x is equal to 6, as 9 and 7 respectively, and we want to find what is the value of the function at f is equal to 5 and what is the corresponding fitting polynomial. So can anyone tell me what should be the order of the polynomial here? We have 2 points. Anyone?
Since 2 points, then I think second order.
Yes, it should be the second order polynomial. Okay, so we'll solve this problem. Okay, we have x node is equal to 2, f node is equal to 9, x1 is equal to 6, f1 is equal to 70, and our polynomial function should look like this. For x minus 6, for the first value, I should write it like this. L naught times x naught and L1 times x1, and L naught here should be x minus x1 and x naught minus x1. Am I right? Is this correct? Anyone? Okay. And what should be the L1 here? It's the x minus x naught, x1 minus x naught, x minus 2, 6 minus 2, x minus 2 by 4. So our polynomial becomes x minus 6 by 4 times f node is 9 plus 17 times, so it comes out to be 17 by 4 minus 9 by 4 x plus 54, this is 2, 34. So what is the answer here? Anyone?
2x plus 5.
What is?
2x plus 5.
2x plus 5. Okay. And for what is p5?
15.
Yes. So this is a kind of powerful technique where using only 2 points we have constructed a polynomial function which turns out to be a linear polynomial. It's not a second degree. Since it's someone was asking about it should be the second order polynomial, but since we are starting with the we should have the polynomial such that f of x is equal to a plus a naught plus a1x plus a2x square. So we are finding this a1, these constants also. So if we have like n points, so we will get the n minus 1 ordered polynomial. Is this clear now?
Yes, sir.
Okay. Now we should do one more example here. Okay. X f of x. We have a function such that this is a relatively easier answer, so I want you to guide me throughout this example. So what is the corresponding second order polynomial? So can you tell me what should be the L node here? L node, F node, L1, F1, L2, F2. Anyone help me? Okay,
X minus X.
X minus X1 and
X minus X.
uh,
Minus X1.
okay,
Minus X.
next what should be the values here?
X minus X2. X minus X.
So x1 is 1 and x2 here is 3. Yes, 0 minus 1, it's 0 minus 3, and what should be the L1 here? X minus x node, x minus x2 over x node minus x1, x node minus it's x1 minus x node and x2 minus x node. So what is x node? 0. And what is x2? What is x2?
3.
Yes, exactly. And it's 1 minus 0, 3 minus 0, 1 by 3 x times x minus 3. And what is L2? X minus x x0, x minus x1, x2 minus x0, x2 minus x1. So it comes out to be 3 minus 0, 3 minus 1. Is it correct now? Anyone?
Okay.
So what should be the px now? We have L0, L1, L2. We know F0. F0 was 0, so it's 0 times 1 by 3 x minus 1 x minus 3, and this is L1 is 1, so it comes out to be 1 by 3 times x minus 3, and F2 is also 0, so it will reach to 0. So our polynomial function becomes 1 by 3 x square minus 3x. So this is a second order polynomial since we have 3 points. So anyone has any doubt in Lagrange interpolation method? Okay. We, so now we are proceeding towards the next method which the instructor has introduced, which was Newton's method. So can anyone tell me how the polynomial function looks like in Newton's method? Anyone? Okay, I'll introduce you. Yes, yes.
Plus a1 bracket x minus c1,
A naught plus a1 x minus.
c1
Okay,
plus a2
okay,
x minus c1 into x minus
okay, and so on. So what are the C1, C2, and the
c1 is x1,
C1 is x1,
a naught is fx1,
A node is fx1, f of, oh sorry, f of x1, okay,
a1 of x2 minus f of x1 upon
f of x2 minus f of x1, x2 minus x1, and oh, so you are starting the counting with the x1, x2, and this. Am I correct?
yes sir.
Okay. And f1, f2, and so on. So, and what is a2?
Sir, I haven't completed that lectures.
Ah, okay, not a problem. It's easier now. It is f of x2 minus f of x1. Okay. So here, since we have the 3 points, so we'll find it out like this. It is easier to remember. It's f of square bracket of x2 comma x1. Okay, which is the difference between these, like first and the third term? F of x2 minus f of 3 minus x2 f of x3 minus f of x2, and this is x3 minus x1. So okay, anyone has any doubt regarding this? Because we will use these coefficients and this equation for solving the next set of questions. This is a good time to ask the doubts here. Any kind of doubt?
So sir, c2 will be x2.
C2 will be the x2, yes. Yes, exactly. Okay. So we are proceeding with the question. The question says, like, we want to find a polynomial function such that it will pass through the following points, which are -1, the corresponding value is 3, 0, -3, 3, 39, 6, 822, 7, 1611. Okay, since we have here 1, 2, 3, 4, 5 points, so what should be the order of the polynomial?
4.
Yes, fourth order polynomial. So we want to find out here f of x I plus 1 minus f of xi by xi plus 1 minus xi. We'll make a table of this. Okay. So what should be the value for the first term? That is the difference between these two. The difference between these two is -6 minus 3, 0, which comes out to be -9. The difference between these two and divided by the difference between this, which comes out to be, let the entries name to be f1 of x. So f1 of x, f2 of x is comes out to be 39 plus 6, 3 minus 0, which is 45 by 3, it's 15. And f of 3 is 822 minus 39 by 6 minus 3. This comes out to be 261. And what is f of 4? 1611 minus 822, 7 minus 6, it's 789 by 1. Anyone has any kind of doubt or any problem here what I am doing here? Are you following me?
No sir, no doubt.
Okay. So it comes out to be 261 and 789. Next we'll find the difference between these two, like following the same thing, which is the like the second order thing. Basically it's f prime. It's not, I should not say it should be a prime, kind of f double prime. This one is f prime of 1 comes out to be 15 plus this and this minus this. this is 6. This and this, which is 6 minus 0 and 261 minus 15. Two 46 by 6 comes out to be 41. F3 double prime of x is 789 by minus 261 by 7 minus 3. 4. It's 789 minus 261 by 4. 132. 41 and 132. So the difference between this and this, which is 41 minus 6, and it's 6 plus 1. 35 by 7 comes out to be 5. 7 minus 0, 7 minus 0, it comes out to be 132 minus 41, so 1 and 91. By 7. 5 by 13. F1 triple prime x 13 minus 5 by 7 plus 1. Anyone has any doubt how we have we end up this table?
No, sir.
Okay, 1 second. So let's copy this table first. So here to write the polynomial, you can see this is the thing we required for our coefficients for finding this. So our function comes out to be p of x minus x1, which is 1, x minus x2, which is 0, plus 6 times x plus 1, x minus 0, oh sorry, and 5 times x plus 1, x minus 0, x minus 3, x plus 1, x minus 0, x minus 3, and x minus 6. Okay, anyone has any doubt here? So what should be the your after calculation? This is a trivial calculation. What is your answer here? Can you give me your answer? What should I solve here? Rafat? Okay, Arfat is solving. Anup? Satvika?
It's solving.
Okay, you're also solving. So when you are done, then give me the answer. Anup?
So solving.
Okay, so I'm waiting. Starting from the last term, we have, okay, for the last term, on simplifying it, we got x plus 1, x minus 3, x minus 6. Let's give it a name. Let us give it q0, q1, q2, q3. So q3 is x times 4, and we're getting it as, okay, it will be easier to do it like this. X square minus 9x and plus 18, x plus 1 comes out to be x cube minus 9x square plus 18x, x square minus 9x plus 18, minus 8x square plus 9x plus 18. So x for 8x cube plus 9x square plus 18x. For the last time you got this? Anyone? This is x square plus x minus 3, x cube minus 3x square plus x square minus 3x, 5x cube minus 10x square minus 3x, and for q1 x plus 1 times x, 6, so 6x square plus 6x, and for q0 it's minus 9x minus 9. So our thing is a plus q0 plus q1 plus q2 and q3. A was 3 minus 9x minus 9, plus q1, which is plus 6x square plus 6x, q2 5x cube minus 10x square minus 3x, and q3 is x4 minus 8x cube plus 9x square plus 18x. So anyone has completed this?
X to the power 4 minus 3x cube plus 20x square minus 6.
20x square minus
6.
are you sure? Because Arafat has written this is the answer from Satvika. From Arafat has x4 3x cube plus 5x square minus 12x minus 6. So I think Anup will be the deciding person. So what is your answer?
Sir, I have got the second one. So Arafat one.
Which one? This one?
The Arafat one. Yes, sir.
Okay.
Sir, I think I have done some mistake
So
in
because
calculation.
it's 2 to 1, so I have to okay. So this method is clear to all, I think. So we can do one more question if you think is required. Can we do one more question for this?
Yes, sir.
Okay. So now similar kind of question. We want to find the polynomial function, and with subject to given these values of x 1 3 4 5 7 and 10 3 31 69 131 351 1011. So this time you will have to help me for this question. I'll just write down I will just complete the table here, I will not solve. So what should be the value here? Anyone? It's 31 minus 3 by 2. F prime of x2 69 minus 31 by 4 minus 3. What is here? Are you solving with me?
Yes, sir.
Okay. So if required, I can wait here for 5 minutes, and if you will help us for solving this question. Anyone from the student side? Or should I solve it with you? Okay, I'll try. uh, f prime of x3 comes out to be 131 minus 69 by 1. It is 262.
So next one is 110
It's 110.
and then 220.
220. Nice. Now this table. F double prime of x1 just 38 minus 14 by 3. It's 4 8 x2 62 minus 38 by 2. Okay, and 6 and 26. This is 38 now. 38 minus 62 minus 38. No, it should be 4. Well, 8. Now 110 minus 62. And it's 7 minus 4, 3. It's 110 minus 5. Comes out to 22. This is correct. Now it's 12 minus 8 by 5 minus 1. 1. This is 16 minus 12 by 5. It comes out to be 7 minus 3, 4. Minus 4, 22 minus 16. this is 1 1 1. Everybody got this results? Everybody? Okay, Arafat has got this. So the next will be 0 0 and this is 0. So let us copy
I
this.
have also got.
Yes. So shall we proceed?
Yes, sir.
Okay. So this is a table we get. So what is the polynomial? Three x 3 plus 14 times is this correct? So on solving this further we got 3 14x minus 14 x square minus 4x plus 3 times 8 x minus 1 times this is same, comes out to be 14x. So we can solve it in the later steps. 3 plus 14x minus 14 plus 8x square minus 32x plus 24 plus x cube minus 4x square plus 3x minus x square plus 4x minus 3. On simplifying it we get x cube so 5x square I made some mistake here I think. Okay, let's proceed. Let's see. Minus 12 this is 7 21 and if we subtract it from 21 it's minus 10x minus 3 it's minus 17 7 10. Anybody else got this answer? I think I have made some mistake either earlier or I don't know. Anybody? Rafat? Anup was solving.
Yes, sir.
This is correct?
Sir, I haven't solved it completely further.
Okay. Anup?
Sir, solving.
Satvika?
Sir, solving. Last step.
Okay. Then let me know. I'll proceed after that.
Sir, in the results previous step. No,
Where?
sir. No, sir. The step right before the answer. This part means.
This
Yes,
one.
sir.
Okay.
Here the last three terms aren't matching with mine.
So what are your
Sir, I have -4 multiplied with those terms.
-4? Okay, yes, it should be. You're right. -4, 16, and it should be
-12.
-12. So now the answer comes out to be
Sir, doing.
what is? I think your mic is off.
Sir, doing the last step.
So you're doing okay. X cube. So this comes out to be 0 x square plus -12 32 16 3 4. It comes out to be x. So this it comes out to be x. And this is -12 and 3 24 and 3. It's 12.
+1.
Plus 1. Okay, good. So this is the answer. Anyone else has got the same answer?
Yes, sir. X
Okay.
cube plus x plus 1.
Okay. Now these are the interpolation techniques we have learnt till now. Using these interpolation techniques, we are constructing a kind of polynomial, and using that polynomial, we'll find the we can find the in between values. So now changing our gears. So in the last part of this lectures, the instructor has taught us about the different statistical terms which are required for the next lectures, I think. Yes, they are required for the next lectures. So he has given us some revised us some definition. So what is the mean value? Could anyone tell me? These are the simple things we have learnt in our like junior high school classes. So what do we mean by the mean of data or of a term?
Sum of data divided by number of data.
Exactly. It's the it's the sum of all the terms divided by the it's the average of
It's
the
like average.
yes, it is the average summation of xi by I. And what do you mean by the standard deviation there? Standard deviation. Standard deviation is the deviation from the mean. So we calculate it by the if we have n points. Standard deviation or ST. Next comes out to be variance, which is the square of the standard deviation. It is n minus 1 xi minus x bar square. Yes. And the third is the coefficient of variance, which is standard deviation times mean. So these terminologies or these concepts we will need to solve further we will need to solve further the we will learn about least square fitting and linear regression tests. For those we require these terminologies, and also while calculating and while reporting some results in either in the financial market or in the lab experiments or somewhere, we should give we will report the results in the term of mean, standard deviation, and we are interested in what are the variance and the distribution of our data. So how our data is distributed basically. So we will learn about this in the further lectures basically from the instructor, and we'll talk about this in the next session. So anyone has any doubt regarding we have what we have done today or any other?
No, sir.
Okay.
No, sir.
Okay. And any feedback regarding these interaction sessions?
Sir, I have a doubt in assignment. Can I ask?
No, I cannot discuss the assignments since you will be graded on the assignments. Okay, Rafat. Like once the solution will come out, then we can discuss the solutions, but I cannot as it is.
Okay, fine, sir. No problem.
Uh, so, any other suggestion or feedback for the interaction sessions, or now I can see here that the number of peoples have dropped who are attending the interaction sessions. So, what could be the cause for this? I'm just asking, like. Any suggestion for the interaction session?
Sir,
Yes.
sir, can I get the last class lecture, sir? It is my first class knowledge, sir.
So, okay. For the last class, I have uploaded the notes for the last class, and I think there will be on the YouTube also. I have uploaded the video, but the thing is, the audio was not clear in that thing. You can refer to the notes, and if you have any doubt, then you can write a mail, or we can discuss in the next class. Is it okay with you?
Yes, sir. Sir, when will be our next class?
On next Saturday,
Okay, sir.
5 to 7.
Sir, where can we get the notes of previous class, previous session?
Previous session, I think. Okay, you may not have the. So, okay, can you can anyone who needed the notes mail me at Shivam Gupta .pmrf@gmail.com. I think this is the right. Yes. So you can mail me. I'll share the link with you. I think I have asked the like NPTEL team was there to okay. Is it okay with you, Rafat?
Yes, sir.
Okay, you can mail me here. I'll share the notes
Sir, I
Thank you, sir.
also.
there. Okay, yeah, you could also mail me there.
Okay, sir.
Okay. So if you don't have any doubt or anything or any suggestion for the interaction session, we can stop it. Okay.
Yes, sir.
Okay, then bye.
Thank you.
Thank you, sir.